Hi, hello. Yes, students. Yes, topic or chapter gravitation. Okay, so we are continuing this chapter gravitation. So from the chapter gravitation, we are going to the topic acceleration due to gravity of the Earth. Acceleration due to gravity of the Earth. Okay, so we know that Earth attracts every object, right? Earth attracts every object towards its center. So just we can imagine here this object. When I leave the hand from this object will be fell down, right? So it's under motion. It's under motion. When it goes down, it's under motion. So of course, if there is motion, there is velocity. If there is velocity, there is an acceleration. So here the acceleration is due to gravity of the Earth. That is our topic. Acceleration is due to gravity of the Earth. So here we already know that the acceleration due to gravity of the Earth is represented by small letter g. We already learned capital letter g, that is a gravitation constant. That is another thing. Gravitation constant. From the topic universal law of gravitation, we already learned the gravitation constant. Now this is acceleration due to gravity. This is small g. Don't forget, this is small g. And what is this value of small g? We know that the value of small g is equal to 9.8 meter per second square. Meter per second square. What does it mean? It means that when any object freely falling, okay, if suppose it takes 3 seconds to reach the ground, just imagine if an object really falls down and it takes 3 seconds to reach the ground. So what is the velocity in the first second? Its first second, the velocity, sorry, the first second, its velocity is 9.8 meter per second. This is velocity. I'm talking about the velocity. Okay. Okay. The second, what is the velocity? Its velocity is 9.8 plus 9.8 meter per second. And what is the velocity in third second? In third second, the velocity is 9.8 plus 9.8 plus 9.8 meter per second. So what does it mean? It means that each second the velocity is increasing at the rate of 9.8 meter per second. That is the meaning. Each second the velocity is increasing at the rate of 9.8 meter per second. So that is the meaning, the acceleration due to gravity. So acceleration due to gravity of the Earth, that is 9.8 meter per second square. So I hope everyone understood, right? So how we can able to give a statement for acceleration due to gravity? Acceleration due to gravity is the acceleration experienced by a body falling freely towards the Earth. That is what acceleration due to gravity. Acceleration due to gravity, which means that the acceleration experienced by a body freely falling towards the Earth. The acceleration experienced by a body freely falling towards the Earth. That's all. Very simple. Acceleration experienced by a body when it freely falls down towards the Earth. So that acceleration is due to the gravity. So that is why we call that acceleration due to gravity of Earth. Okay. I hope everybody understood. Now, we are going to the next topic, the It's the topic that is relation due to acceleration due to gravity and gravitational constant. So we know that acceleration due to gravity, which means g, small letter g, and acceleration constant, that is capital letter G. So the relationship between the g and g, that means small g and capital letter G. Okay, so small g is acceleration due to gravity, and capital G is the gravitational constant. Okay, let's see. So let's imagine uh, an object having mass m, mass m, small letter m. Okay, at a distance r from the center of the earth, this object is placed at a distance r from the center of the earth. So according to Newton's law of gravitation, we already learned the universal law of gravitation, right? So according to universal law of gravitation, the force experienced in between the earth and this object. So just imagine here is our earth. Okay, here is our earth. Just imagine this is the spherical shape of earth. So the object is here. So from the center, the object is here, and the center to the object. So this is center, and here is the object. Okay, so this distance is your object having mass m, and the distance is r. Okay, so and capital M is the mass of earth. So mass of object, this is object mass. Okay, object mass, capital M. And what is the mass of earth? Earth mass, earth mass, that is capital M. So in that case, acceleration, sorry, force in between the two objects. Here one object is earth. Let's assume one object is earth and another object is uh, our body. Okay, so uh, F is equal to m m divided by r square. According to universal law of gravitation, the force between two bodies, one is earth and another object is our another thing is our body. Okay, so force is directly proportional to m into m divided by r square. So that we can write as F is equal to by changing the gravitation proportionality sign, we can add a constant, that is d m m divided by r square. So F is equal to g into m divided by r square. So let's see here, force acting on mass m. According to Newton's second law, we can write this another one expression for the force. Okay, this is according to universal law of gravitation. This is according to universal law of gravitation. According to Newton's second law, we can write F is equal to force experience. The Earth is attracting this object towards the center. So the object experiences a force, that is mg, mass into acceleration. So instead of acceleration, here the acceleration is acceleration due to gravity. So that is mg. So this is equation. Comparing equation 1 and 1 and 1 and 2. Here you know that these two equations are force only, right? This is force in between two objects, and this is the force experience on the body. So both are force. So we can equate these two equations. So what will come? That is mg is equal to g m divided by r, right? So what is this m, small m? Tell me, what is this small m? Small m represent the mass of the object, right? And what is this small m? Same, but that is also mass of the object. So LHS and RHS, small m is same mass of the object. So let's cancel each other. Okay. So what we are getting? We are getting the expression G is equal to T m m divided by r square, right? Divided by r square. So sorry, we don't want this to write this m. This is already cancelled, right? Okay. So we are getting G is equal to G m divided by r square. So what does it mean? Acceleration due to gravity is equal to gravitation constant into m by r square. Okay. So what is this G? This is the gravitation constant. We know the value already. And m, mass of the earth, we already know. And r square. So the distance from center of the earth to the object. Okay. So if the object is on the surface, suppose just let's imagine if the object is placed on the surface of the earth. So that is the radius of the earth. So this G, this R become radius, right? So G is equal to Gm divided by R square. Then you may get the value by applying all these values. You may get the G value become 9.8 meter per second square. And this is an average value. Okay, this is only an average value. So actually, this value represents the equatorial position of the Earth. But in the polar region, polar region, the value, the G value becomes 9.8 instead of 9.8. That will become there is little bit increase. That is 10 meter per second square. At the polar region, the acceleration due to gravity is 10 meter per second square. Okay, so this is what the relationship between gravitation constant and I will show once again. Uh, this is the relationship between acceleration due to gravity and gravitational constant. So let's see once again. Object mass small m, distance between the center of the earth to the object is r, and capital M is the mass of the earth. Okay, so according to universal law of gravitation, we can write the force in between two objects. Here one object is earth and another object is body. Okay, so F is directly proportional to m divided by r square. Then changing the proportionality sign, we can add a constant, that is gravitation constant G. So F is equal to G m divided by r square. Okay, then according to Newton's second law, we can write the expression for the F, that F is equal to mg. That means the force experienced on the object by the earth. So F is equal to mg. So these both are the expression of force. So while we comparing equation 1 and 2, we can write mg is equal to Gmm divided by r square. Here the small m, LHS small m and RHS small m both are the mass of the object. So let's cancel each other. So what will be remain? G is equal to Gm divided by r square. That is G is equal to 9.8 meter per second square at the equatorial region, and the polar region, that is 10 meter per second square. Hope everybody understood. So I am writing these sections. Thank you. Thanks a lot. And let's see another class. Thank you. Bye bye.